Welcome to PCS Adventures Lab. Today we have the opportunity to interview Michaela for a few moments, and she's going to tell us a little bit about her experience here at Edventures. So Michaela, first of all, I'd like to ask you, how long have you been attending Edventures Lab?
In February, it's going to be 4 years, so that would be from my 7th grade year to now my 11th.
Wow.
In school, yeah.
Yeah, so that's a lot of commitment of time. What has kept you in the lab this long?
Really it's just my niche. It's just what I like doing. I like the hands-on activities. I like making things and figuring stuff out, so.
So it must have been entertaining and engaging for you to stick around this long.
Oh, yeah. It's just, yeah, it's a wonderful experience. I mean, prior to 7th grade, I hadn't had a lot of exposure to doing more science and tech-related stuff, and then once I joined my design tech class at my school, it was just wonderful.
Cool. Okay, so when you've been here in the lab, obviously we have lots of things that are going on here. So people are working in mechanical engineering, structural engineering. They're learning how to program games in 3 dimensions. They're doing 3D printing. A lot of fun things. So let me ask you this, first of all, what's been the most exciting thing for you? What do you find most interesting out of all the stuff you've done here?
I would say programming has been my most exciting experience, just because I'm able to figure out how to make things work in unique patterns and then apply them to, motors and robots and just have fun with them.
Cool, okay. Yeah, in education we call that computational thinking, which you can apply to just about anything in the real world. Do you think that the experiences you've had here have helped you apply things in the real world?
Yes, they've applied just in general with how I've experimented with builds in the lab and then also how I communicate to others in the lab. So I'm able to apply those to my education and to just general speaking with others and trying to figure out how to make things work the best.
Do you think that you're a better student academically because of some of the experiences you've had here?
Yes, because one of the main focuses that you really need to learn while working in these development forms of building and experimenting is that mistakes will happen and failure is always an option. And so that's something very important to apply education-wise, because though some things may not be perfect, you just know you have to learn from what you did wrong or what messed up and then apply them to future experiences.
Wow, that's awesome. Yep, that's exactly how the real world works. Lots of failure involved there in getting things done. That's awesome. So, you're a pretty, you seem to have a very mature outlook on life, and I think you come across as very sophisticated for your age.
Yep.
Have you thought a little bit about your career path and what you want to do when you get out of high school?
Yes. At the moment, my decision is going to go into mechanical engineering for college, and then with that, I'm hoping to take that degree and then apply it to make devices, just things in general in which will help the world be better developed and hopefully not just be making a bunch of crap, really.
So you want to design things to improve the world?
Yes.
Yeah. One of the things that I've read a lot about is as more and more women are recruited to get into STEM fields and engineering, one of the attractive things to women is exactly what you just said. They want to actually build things or design things that are going to improve the world. So that's neat to hear you say that, because I think that actually backs up the research I've seen. And as a girl getting into engineering, were there things that you perceived as barriers, to getting into this kind of thing? Were there social barriers or people or anything that discouraged you from it?
When I first started doing all this, I of course did notice that there was definitely a different ratio of amount of men compared to women in the classes and such, and just in the STEM field in general. And I've just kind of took that advice of being, you need to be careful when you get there, because some men might just put you down because of your gender in this case. But I just choose to ignore that, because I feel like that's more of a limitation than anything else. Because I rather just experience it and enjoy it as well, and not worry about what future causes could happen in which there's probably not a high possibility of them coming true.
Awesome. Do you feel like the environment here in the lab has been very nurturing and welcoming to you as a girl?
Oh, definitely. I mean, all the instructors, they're fantastic, very hands-on. They speak to me in a very equal terms, and which is quite nice, because you typically, when you're going through like school, sometimes teachers will speak down to you because you are the student, but here it's definitely that they're just trying to help you and, you know, develop your learning.
Cool. Awesome. Okay, well, let's move on to the next piece of this discussion. I heard that you had created something amazing with the brain. This is like the most sophisticated thing that we've seen come out of the lab so far. So this must be the product of 4 years of hard work as you've evolved and learned things.
Yeah. So yeah, with my robotic arm, originally this arm was built, I think, last year, and we've put it through a bunch of different programs as our computer programming style has developed, and also the brain in which we download the programs and attach the motors and sensors to.
So why don't you give us a demonstration? Let's talk about this thing a little bit.
All right. So with this, it has a few axes of rotation. So first off, with the base, it'll spin around. With the arm, it'll go up and down, and then with the clamp, it will open and close. So let me turn this on. So
look at that.
And then also something very fun is that it can also like go down and spin at the same time. And go up, and spin again. And so yeah, with this it's just very easily controllable, and I think one of the best programs we've put on this arm so far.
Yeah, so you're actually controlling this with the tablet wirelessly.
Yes.
So when you're tipping the tablet, actually, how does that transmit the information to the robot arm?
So on here we have this accelerometer, in which kind of has an X and a Y axis, in which so when I tilt it down, the arm will go down, so that's going positive in the X axis, and then the Y axis, and then when I tip up, it goes in the negative Y axis.
Okay.
And then to positive X, it goes into, well, it would be my right, and negative X goes to the left.
This is like pure applied Cartesian geometry, isn't it?
Yeah, it is.
So has this been difficult to program?
Actually, this was one of the simplest programs I've done so far. I feel like in terms of what I've done to this robotic arm so far, there was already kind of a preset, program for the accelerometer, and it was just a few more tweaks need to be done. And right now it looks a lot more complex, but it's
Yeah, that actually looks pretty compact in terms of everything it's doing.
Yeah.
So tell me a little bit about the capabilities of the brain. Has it been fairly easy to work with, and does it have all the capabilities you need for something like this?
Yes, it has. Well, one of the most, the greatest kind of addition to it is making it wireless. That's been something that's
fun. Yeah.
Yeah,
that's
super
really
fun, because you can also use it like on racers or we have those sumo contests here with our little big robots in which we kind of battle with these tablets using them. And then also it's able to handle large files of program being downloaded and being applied to the whatever robotic machinery you have.
So I notice you've got one sensor port that's being used. What is the sensor doing on this arm?
The sensor on this arm, so it's attached to this push button right here. Mm-hmm. And so when I hit the compile button instead of the run button. Yeah, so it has this push button right here, mm-hmm. in which the sensor is attached to. And then so something about this arm is that it works on a worm system. Mm-hmm. And an issue that I was originally having was that if it got too low, it was messing up. It would continue going down. But there's no more room for it to go down. Right. And it would just be very icky. But
since your worm's so powerful, it would probably try to break the thing apart.
Yeah, exactly. But now it just stays here.
Yep. Okay.
And you'll still be able to spin it, which is fun, and it just stops. So you can't bring it down anymore and make it break. Mm-hmm. But now, and then you can just push it back down, and everything's all fine with it.
So cool.
Mm-hmm.
Now let me grab something for you to pick up. I want to see
all right.
the fact that we're a little tired though.
Oh yeah.
Okay, so your end effector is a little claw.
Mm-hmm.
So can it actually pick something up? Oh, it
Oh,
does.
yeah.
It moves. I see it.
Yeah. Oh.
It's like you have to be a trained operator for this thing.
Yeah.
Cool.
Oh, all right. And I'll just tilt it down a little bit.
Nice. Perfect.
Yeah.
That is a good example of a pick-and-place robot moving
Mhm.
things around for people.
Yeah.
Great. Well, thank you for spending some time with me today.
Yeah, thanks
Appreciate
for
it.
inviting me.